Good morning, students. Today we'll discuss SAQs from thermodynamics. Today, last class on SAQs. Next topic on next class onwards, we'll continue VSAQs. So, two SAQs, two short answer questions left from thermodynamics. First, define specific gas constant why Cp greater than Cv. Define specific gas constant. Total two specific gas constant present. One is the specific gas constant at constant volume. Second one, specific gas constant at constant pressure. So, definition of specific gas constant with why Cp greater than Cv. First of all, we'll discuss what is the meaning of specific gas constant at constant pressure. Specific gas constant at constant pressure. This is Cp. Next one is their specific gas constant at constant volume. So Cp, definition of Cp means at constant pressure. This word compulsory. Pressure constant. Why we are taking only pressure and volume means on heating. When we are supplying heat to a gas, on supplying heat in gas, when we are giving external energy, nothing but heat energy, one is volume changes, second one pressure changes. Meaning when we are supplying heat, at a time pressure changes and volume changes. That's why one is constant pressure. What is the formula? Second one, constant volume. What is the formula? Definition Cp, definition Cv. At constant pressure, this is the formula for Cp. At constant pressure, heat supplied to a gas at constant pressure. The amount of heat required to supply heat. What is the how much amount of heat? 1 mole, like that practically we are going. This definition, single line, at constant pressure. Pressure constant. Definition starts with pressure constant. Next definition starts with constant volume. The amount of heat required for a gas, unit mass of the gas, to rise unit temperature. That is 1 degree Celsius or 1 Kelvin. That is nothing but constant pressure. We are writing at constant pressure. At constant pressure, heat, the amount of heat required for unit mass of gas to rise unit temperature. So, student, at constant pressure, we need heat to rise one temperature of 1 gram or 1 kilogram body. That is nothing but Cp. At constant pressure, amount of heat required for unit mass of gas to rise unit temperature. This one only Cp equals to 1 by m into dq by dt. Units, SI unit students, joules. Joules for heat energy, kg Kelvin. Joules for kg Kelvin is the SI unit for constant pressure. First of all, specific gas constant at constant pressure. At constant pressure, amount of heat required for unit mass of gas to rise unit temperature. This is the Cp. Definition of Cp, definition of CV. Why CP greater than CV? Next one, specific gas constant. Specific gas constant at constant volume. Now, here student, CV. CV equals to 1 by m into dq by dt. Joules per kg Kelvin. Here, the amount of heat required, the amount of heat required for unit mass of body, unit mass of body to rise unit temperature. This is CV. CP, CV, CP. P stands for pressure. V stands for volume. Gas constant at constant volume. Previous gas constant at constant pressure. Okay. Define specific gas constant. Why CP greater than CV? Specific gas constant at constant pressure. Definition starts with pressure constant. Pressure constant, the amount of heat required for unit mass of body, meaning unit mass of gas to rise unit temperature. Here, the amount of heat required for unit mass of body. We are going body, we are going gas, anything, no problem. To rise unit temperature. Why CP greater than CV? Why CP greater than CV means, students, here? Why CP greater than CV means at constant pressure, at constant volume. We are supplying heat at constant pressure. We are supplying heat at constant volume. When we are supplying heat at constant pressure, this heat utilized for internal energy plus external work. Because when we are giving heat, it utilized for two cases. In the case of pressure constant, we need heat for two cases. What about at constant volume? dq equals to du, because dw equals to pdv, 0. There is no change in volume, meaning heat required for only internal energy, heat required for internal energy and for external work. That's why, student, where we need more heat means at constant pressure. That's why CV with dq both are directly proportional. We are writing like this. Just a single point. See, at constant pressure, heat required. At constant pressure, heat required for body at constant pressure, heat required for body to increase internal energy and external work. But at constant volume, heat required for only internal energy. So, more heat required. So, more heat required at constant pressure. Therefore, CP greater than CV. Is it clear, student? Now listen carefully. This is the question from thermodynamics. Define specific gas constant. Why CP greater than CV? At constant pressure, heat required for unit mass of the body to rise unit temperature. Cp equals to 1 by m into dq by dt. At constant volume, heat required for unit mass of gas, unit mass of body, anything, no problem, to rise unit temperature. Cv equals to 1 by m into dq by dt. So, student, more heat required at constant pressure because heat required for internal energy and for external work. That's why more heat required at constant pressure. Therefore, Cp greater than Cv. This is the question number 1 for this day. Last question from this total intermediate first year, last SAQ. Derive relation in between. Derive the relation in between molar specific gas constant. Molar specific gas constant, meaning Cp minus Cv is equal to R. In examination, they are not giving direct word Cp minus Cv is equal to R. Derive the relation in between molar specific gas constant. Cp minus Cv equals to R. Now, here, student, first, this is the gas. 1 mole ideal gas. Ideal gas means which satisfies, which obeys in all conditions Boyle's law and Charles' law. 1 mole ideal gas, student, filled in cylinder. We are supplying heat at constant volume. At constant volume means Cv equals to 1 by n into dq by dt. N nothing but number of moles. Now, here mole nothing but mass measurement for gas. N equals to 1. Then what is the value, student? dq equals to Cv dt. Just now I said at constant volume means heat required for only internal energy. That is why we wrote dq equals to du. This is the question, equation number 1. Derive the relation in between molar specific gas constant. Molar word coming means number of moles, n notation. Previous mass, m notation. Numerically, both are same. Cv equals to 1 by n into dq by dt. dq equals to Cv dt. That is nothing but at constant volume, internal energy. Now, here, same concept we are taking at constant pressure. Cp equals to 1 by n into dq by dt. Again, n is equal to 1. dq is equal to Cp dt. Equation number 2. So, student, first law of thermodynamics. First law, dq equals to du plus dw. Now, see, substitute equation 2 and 1. In this one, substitute equation 2 and 1. dq Cv dt. du Cv dt. One is Cp dt, one is Cv dt plus dw. Plus coming left side minus. Now, here Cp dt minus Cv dt equals to dw. Work equals to pressure into volume. This is the formula for work done by the gas, work done on the gas. In the case of thermodynamics, student, dw is equal to pdv means you take dt common. Cp minus Cv pdv. 1 mole ideal gas equation, PV is equal to nRT. N stands for 1 mole. P constant, differentiation dV. R constant, differentiation dt. Substitute. dt Cp minus Cv or dt. dt cancel. Cp minus Cv is equal to R. This equation within few minutes I am giving in 4 lines student shortcut explanation. First of all, today question number 1 starts with now here. Define specific gas constant. Why Cp greater than Cv? Specific gas constant means mass term coming. Formula M. Molar specific gas constant means N coming. Both are same. One is for N. Number of moles coming means gas. Only for gas. Remaining means gas, other than gas. Solids also no problem, students. So, Cp, Cv at constant pressure, this definition, heat required for unit mass of gas to rise unit temperature. This is the definition of Cp. Definition of Cv at constant volume, heat required for unit mass of body to rise unit temperature. Why Cp greater than Cv means at constant pressure, heat utilized for 2 cases, at constant volume, heat required for 1 case. That's why more heat required at constant pressure. Therefore, Cp greater than Cv. Now, derive the relation between molar specific gas constant. Within few minutes, I am giving shortcut explanation, student. First, 1 mole ideal gas filled in cylinder at constant volume. Heat we are supplying at constant volume. Cv equals to 1 by N into dq by dt. N stands for moles, 1 mole. dq equals to Cv dt. This dq is equal to Cv dt at constant volume. Heat nothing but only internal energy. At constant pressure means same formula we are writing. dq is equal to Cp dt. From first law, dq is equals to du plus dw. Cp dt equals to Cv dt plus dw. What the dw means? Pdv. This is the formula for work done. What is the dw pdv means? We took ideal gas equation, 1 mole ideal gas, differentiation. P constant, change in the volume. R constant, change in the temperature. R nothing but universal gas constant. Universal gas constant 8.314 joules per mole Kelvin. That is a standard value. But in examination, don't want that one. PdV is equal to RdT. dt cancel. Cp minus Cv is equal to R. This answer within few minutes I am giving in short way. See, Cp minus Cv equals to R. This is the ideal gas. Heat supplied at constant volume. Students here, dq is equal to Cv dt in question 1 because N is equal to 1. At constant pressure. One more equation. First law of thermodynamics. dq is equals to du plus dw. dq means Cp dt, du means Cv dt, dw as usual we are writing Cp dt, Cv dt, dw is equal to pdv, pdv is equal to rdt. You are writing like this. dw is equal to pdv, pdv is equal to rdt because of ideal gas equation like this bracket. Now see dt common. Cp minus Cv is equal to rdt. Cancel each other. This is the short way for Cp minus Cv is equal to R. Okay, student. So today last two questions I finished. One is why Cp greater than Cv, definition of Cp and Cv. Second one, short method, derive the relation between molar specific gas constant, Cp minus Cv equals to R. Okay, student. Now, here up to now, how many LAQs and how many SAQs I finished? Just I'm writing on board, including problems. Including problems. Total 4 LAQ student you are reading. I finished 4. From that one, 2 coming. One is law of conservation of energy. Freely falling body. Freely falling body. 5.4 kilowatts. This is the problem number 1 for law of conservation of energy. Define work kinetic energy, work energy theorem. For this one, 2 problems, students. One is 15,000 watts. Next one, 170 HP. Power of motor. Power of motor problems. Next, define SHM. Particle motion SHM with respect to diameter. When a particle moving in circular path, particle motion SHM. Problem 5/4 radians. Sorry, 4 plus 2, 6. 4 plus 2, because you are reading only 4 out of 6. Next, time period of simple pendulum. For this one, 3 different concept. Ticks of pendulum. Second pendulum definition. Length decreased by 7/16. So this 4 enough. If possible, you read 6. Otherwise, said now 4 plus extra 1. I finished more 2 questions. Newton law of cooling. Finally, you are reading minimum 4, maximum 6. Newton law of cooling, surrounding temperature 28.3. Last one, Carnot engine, reversible, irreversible process. Irreversible, comma, reversible. So, student, this 6, if possible, you read 6. Otherwise, minimum 4. First 2, second 2. Otherwise, second 2, last 2. Otherwise, first 2, last 2, like this. 4 plus any one extra 1. Minimum 4, maximum 5. From this one, you are getting 100% to LAQs. This is for 2 LAQs purpose. I explained 6. Now we are going towards SAQs. Satish, phone incharge kinda. SAQs. Number 1. Parallelogram law. State and explain parallelogram law. Next one, path of projectile. Parabola. Number 3, define maximum height range with equation u square by 2g sin square theta, u square by g sin 2 theta. This is the range. This is the maximum height. Next, modulus of a plus b equals to modulus of a minus b. Angle between AB. Next, define momentum, impulse, law of conservation of momentum. Examples. Okay, this 5. Next, 6th one. This one already I gave student. If you are getting doubt, check this total videos from day 1 onwards. Sixth one, lawn roller. Pulling is better than pushing. Lawn roller students. Next, method of decrease friction. Loss of rolling friction. Next, center of mass and gravity difference. Next, vector product. Example with properties. Next, define angular velocity. V equals to R omega. This is all finished questions from this many days onwards. Next, orbital velocity. Next, escape velocity. Kepler laws. Geostationary satellites. Stress types. Strain types. Don't think more this many questions I'm reading. From this one, I will give you in upcoming classes direct guess question student. This one finished questions up to now in class. So strain types, stress types. 17. 18. Behavior of loaded wire. Strain energy, elastic potential. This one only. Anomalous behavior. Advantage of anomalous behavior. Relation between Celsius with Fahrenheit scale. Triple point. Conduction, convection, radiation. Yesterday topic student. Why Cp greater than Cv? Cp minus Cv is equal to R. So that H max equals to 1/4 of range. Condition for static friction. So student, this many questions finished. Parallelogram law, path of projectile parabola, define maximum height, modulus of A plus B, momentum, law of conservation of momentum, lawn roller, decreasing methods of friction, rolling frictions, loss of rolling friction, center of mass, center of gravity, vector product, angular velocity. These 4 questions from single lesson: gravitation, orbital velocity, escape velocity, Kepler laws, geostationary satellite, stress types, strain types, strain energy, behavior of loaded wire, anomalous behavior of water, relation between Celsius, triple point, conduction, convection, radiation. Why Cp greater than Cv, Cp minus Cv is equal to R. Static friction concept also over, including problems. Which problem? One is the multi-story building. Next one, a car, average speed 18 kmph. Next one, torque problem. This is the topics I covered up to now. LAQs over, SAQs over. One more student, most important question I forgot here. 28. S is equals to UT plus half AT square. Graph method. Okay. More to there. This is the 3 problems, student. More to that one conceptual question. Now will be explanation. Total 30 SAQs I finished with 3 problems. Total 6 LAQs. More to SAQs. Now I'm giving explanation. That one simple question, student. And 3 problems. So I'm writing here. See. 6 LAQs. 30 SAQs. 3 problems. This is all covered. Total 30 SAQs means 28 over means that 29 and 30 here. There one conceptual question. Number 1. A bird parachute question is there. One is the bird. A bird holds a bird bringing some fruit. Question: a bird holds a fruit in its beak. One bird delivered, one bird is released, one fruit. What is the motion of the fruit with respect to bird? This is a conceptual question. What is the motion of the fruit with respect to bird? It is released from certain height. What is the motion of the fruit with respect to person observed from ground? So, question here, I'm giving just one diagram understanding purpose. Not bird. So, one bird released fruit like this. There. This one coming like this. Here, what is the motion of the object? Object nothing but fruit. Motion of object with respect to bird. You know, any body moving from certain height, one body released. With respect to bird, it is moving vertically downwards, meaning with respect to bird, its motion. Motion of fruit. Freely falling body towards ground in vertical direction. So, what is the motion of the fruit with respect to bird means it is moving downwards. Under gravity, it is moving. With respect to bird, the motion of fruit is freely falling body towards ground in vertical direction. What about person? With respect to person, its path is parabola. So, one person watching from ground, it is looking like parabola shape. What about bird means vertically downwards? These two. Here 2 marks, here 2 marks. This answer is looking like VSQ, but 4 marks question. Next question, student. Can the velocity of an object other than the direction of acceleration? So velocity direction, acceleration direction, different directions, possible or not? So answer starts with yes. Yes, meaning velocity direction and acceleration direction both are in different. Yes, in the case of vertically projected body, in the case of vertically projected body like this, velocity direction upwards and acceleration due to gravity downwards. Acceleration due to gravity downwards. One example enough, student. Other than this one, projectile case is there. Other than this one, simple pendulum case. You write one example. Velocity direction other than the direction of acceleration. Give an example. They're asking give an example. An example means one example enough. Yes, it is possible. In the case of vertically projected body, velocity and acceleration both are in opposite direction. So, student, these two and previous 28, total 30 SAQs I finished, 6 LAQs over tomorrow and day after tomorrow, 2 days, our focus on VSAQs. From this one, the final day, I will give you one important list, thought out program is there. You read that one, 100%, 50 plus coming, 50 plus guarantee if you are reading this one up to now, including VSAQs. Okay. So VSAQs left, 6 VSAQs coming out of 10, 6 VSAQs from 3 lessons. We'll continue in next class, tomorrow class. Okay, right.